Exercise 23.3, this is question 6. Draw the graph of the function 2x squared minus x minus 3 in the domain minus 2 less than or equal to x less than or equal to 3. Use your graph, okay? So we've got to draw the graph. Now, I've told you guys already that you have to actually do the form, you have to show all the workings, okay? Because I've shown you this, I don't know how many times already, we're just going to skip straight into the calculator mode, take down the points and draw it, okay? Okay. So what we're going to get here is table mode, and what we're going to get is 2x squared, 2x squared minus 1x minus 3, okay, then we're going to start at minus 2 and we're going to end at minus 3. Alright, will somebody math error, that is interesting when that happens. Okay, let's see what we can do with that.
You just have to go you ended it at 3.
Ah. Gotcha. That's my maths error there, minus 3. So everybody knew that but me, alright? So guys, what we're going to have is these points here. Has anybody got all these points listed out already?
Yeah.
If so, can you call them out to me? The first one, if I remember correctly, was minus 2, 7. What about the next one?
0 or
minus 1, 0.
Yeah.
Next one?
0 minus 3.
Yeah.
1 minus 2.
Yeah.
2, 3.
Yeah.
And then 3, 12.
Okay. Unusual. Yeah, you're right. Okay. Now that this is done, we're going to draw. Now, what's our y max and y min? Y max?
12.
Y min?
Minus 3.
Minus 3, so it's actually not too bad, okay? So I reckon we can go up in we can probably go up in 2s, can't we? We'll see now. Okay, so we're going to draw our line here. We're going to start off with 12's the biggest one, so we'll start off with 12 around here. Okay, 12. What I say, we're going to make every gap worth. Well, actually, we'll just do every gap is worth 1, alright? It's probably easier this way. Actually, 10, 8, 6, 4, 2, 0, minus 2, minus 4. Stop there. Okay? Next thing we're going to do is going to draw the axis across like so, or the x-axis across, and we're going to draw numbers from 1, 2 to minus 2 to 3. Now I'm going to make it gaps of 3 here, and I'm going to tell you why, just to make it a bit more, space it out a bit more, we'll get a more accurate result this way. Okay, 1, 2, and 3. So what have I done? Somebody might have a diagram like this. What I've done is I've widened it out a little. Still the same diagram, just looks slightly differently. Okay, so now we're going to draw our points. Let's draw our points. Minus 1, 0. Oh, sorry, 2, 7. Minus 2, 7. Here. What's the next one? Minus 1, 0. Here. 0 minus 3. Located here. 1 minus 2. Located around here. 1 minus 2. What about 2, 3? 2, 3. 2, 3 is here, and 3, 12 is in here. Now guys, how many people would be confused as to how to do this turn here? Do you stop here and go around, or do you go down a little and back up again? Who would know? Nobody knows, correct? Now I have a plan for that. Here's my plan, okay? There's a problem in between x equals 0 and x equals 1. So let's do the same thing again. Okay. Except this time start at 0, end at 1. Make the gap much smaller. Let's talk point 1 or point 2. Now look what happens this time. I now find out what point 1 is, I find out what point 2 is, I find out what point 3 is, I find out what point 4. See the way 0.2 and 0.3 is minus 3.1? We can tell from that that 0.25 is the minimum. So if I do something like this, 0.25, what did we say it was? It's minus 3.1, yeah? So what I do is I go to 0.2, to around here, and go down to 3.1, and now I automatically know that that's my minimum point, and then I can draw my graph a bit better then, okay? So that's just a little trick you can do to make your graph more accurate, right? So you're just going in here. Now that's the bottom point there, okay, roughly. Now we're on our way back up. There we go. Right, that's our graph there. Now you can see I'm a bit wobbly here, haven't I? In a test I'd have to steady that up a little bit and rub it out, okay? Now guys, questions. Use your graph to find when the value for x for which f of x is 0. What does that mean? Now what's the 2 points? X equals 1 and x equals 1.5. Who got that? 1 and 1.5-ish?
Minus 1, sorry.
What?
Minus 1.
Oh, minus 1, sorry. Minus 1 and 1.5. Find the values for which f of x equals 6, where the y value equals 6. What do we get this time? What do you want to call that one there? That's minus 1.3, minus 1.67. It's very close, about minus 1.8, minus 1.9 somewhere.
Yeah.
So let's go for minus 1.8. And what's the other one? 2 1/3, 2.3. Or 2.33. Okay? Find the coordinates of the minimum point on the curve. Well, we just sort of did that, didn't we? Now, lads, let's say for instance I want to see what happens. It's going to be 0.25, isn't it? How do I know it's 0.25? Because 0.2 and 0.3 are on the same level as each other. How do I know they're on the same level? See the 3.12 and the 3.12? Yeah? I know they're on the same level, which means that in between is going to be the lowest point, isn't it? And what do we know about the lowest point? We only have to estimate it, so we can say x is 0.25 and y is, take a guess, is it going to be bigger or smaller than minus 3.12? Is it going to be higher or lower?
Lower.
Lower. Call it minus 3.2. It's only an estimate anyway, so call it minus 3.2. Okay, that's the minimum point. Done. Find the values of x for which f of x is less than 0. What does f of x smaller than 0 mean? Sorry? When it's smaller than 0. When does that happen? When does it start? Starts here. It's neutral. Now it's smaller than 0, smaller than 0, smaller than 0. Stops there. So it starts at x equals minus 1. So it's the numbers between minus 1 and 1.5. So it's going to be minus 1 less than x less than 1.5. Mr. Farrell, you have a question? Alright guys, once again, on the same axis on the same axis and the same scales, graph the function f of x equals x squared plus 3x minus 3. Okay, so f of x equals x squared plus 3x minus 3. And it starts at minus 4, ends at 2, step of 1. Does anyone in the class have all these points ready to go? Anybody? Brian again, yeah? Okay, Brian. So guys, you would have to write down all the workings. Does everybody know how to do the workings? You replace the formula with whatever number you're talking about, okay? We did it in the previous question. So we're just going to write down the points here. So what's the points?
Minus 4 and 1.
Minus 4 and 1.
Minus 3 and minus 3.
Minus 3, minus 3. Yeah.
Minus 2 and minus 5.
Minus 2, minus 5, yeah.
Minus 1 and minus 5.
Yeah.
0 minus 3.
Yeah.
1 and 1.
1 and 1. Yeah.
2 and 7.
2 and 7. Guys, I already know where the minimum point is going to be. How do I know that? How do I already know where the minimum point is? What's the lowest value of x? Minus 5, isn't it? And that's going to be minus 5 on the y-axis, so is this. Now, what is halfway between the two minus 5s? 1 point, minus 1 and a half. Do you see the x equals minus 2, x equals minus 1? That means that the minimum point is going to be located at minus 1 point.
No, y is minus 5.
Yes, that's the y value. And the x value is this way, yeah?
Yeah.
Okay. So guys, we already know that the minimum point is going to be x equals minus 1.5. Okay, that's grand. Now, before we even go about drawing that, what we should do next is we should get the line's values. Okay, the value of the line, which I'll do in green. So let's get the points on the line. So once again, you go back to your function, and you do, this time you do x minus 2. And you start at minus 4, you end at 2, you step at 1. Minus 4, minus 6, 3 minus 5, 2 minus 4, 1 minus 2, minus 3, 0 minus 2, 0 minus 1, 0, 2. Will somebody call out those points for me now? Anybody have them ready to go? Anybody have the points to the line ready to go? Do you want me to do it again on the calculator? You write in f of x equals x minus 2. Your start is minus 4. Your end is 2. Your step is going up in ones. These are my points. How many people have the points on their calculator now? Thank you, Oscar. Oscar, can you call them out for me, please?
Minus 4, minus 6.
Yeah.
Minus 3, minus 5.
Yeah.
Minus 2, minus 4. Minus 1, minus 3.
Yeah.
0, minus 0.
Minus 2.
Yeah. 1, minus 1.
2, 0.
Yeah.
Okay guys, now stop here. Okay. Now the reason why I did this first is this. Okay, I'm just going to drag this down for a minute. Now, what we're going to do is, you should always have your one, green is line, blue is curve. Do you got that? Green is line, blue is curve. What we have them is in here, okay, to the sides. Now guys, looking at both graphs, what is my y max between both, including the line and the curve? Which is y max? Our biggest y value?
6.
Sorry?
7.
7. Y min? What? Minus? So we have to go from 7 all the way down to minus 6. Okay. I'm confident we have around 27, 26 blocks here. We'll find out once again in pencil. Right, you're just going to be very careful with this. Right, 7, 2 gap 6, 2 gap 5, 2 gap 4, 2 gap 3, 2 gap 2, 1, x-axis, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. I have just about the right amount of space for that. That's why you do it in pencil, to make sure you can do it. If I couldn't fit it, what would I have to do? Each one is only one block as opposed to 2 blocks, okay? Then I draw my x-axis in. Once again, the bigger the gap, the better. Right, so it goes from minus 4 all the way up to 2. So let's see if we can do this. Right, in 3 is minus 1, minus 2, minus 3, minus 4. 1, 2, 3. Fit perfectly, didn't it? Okay, let's do our graphs. Starting off with the blue points. -4, 1, located here. -3, -3, locate it down here. -2, -5, locate it down here. -1, -5, locate it here. Now what did we say about there's a point in the middle? Where is the minimum point again? Does the graph go directly across? It's curved. How do we find out this minimum point? We replace x with -1.5. Will somebody be so kind as to do this in their calculator right now? -1.5 squared plus 3 times -1.5 minus 3. And tell me what number we get out.
Minus a quarter, minus 3/4.
It should be bigger than that. It should be -5 point something. Did you put -1.5 in?
No.
Okay. Go again.
9.75.
Use brackets on the 1.5 squared.
No, I got -9.75.
Did you use brackets on the 1.5 squared?
-5.25.
That's what I'm talking about. Okay. -5.25. -5.25 is the minimum. That there is 5.5 and 5.25 is around here. Why do I do that? To prevent you from doing this. Do you understand? So if I do this, which is in class, it teaches you that the curve is more gradual of a turn, not a big dip down. Okay, that's why I'm doing it. That's why I calculate that to get it accurate. Then we're going to go down. Okay, and then we're going to go back around again. Now where's the next point? 0, -3, 1, 1, 2, 7. 2, 7 is located up here. Alright, so now we've got to keep it steady. Okay, if you're to spot an error, that's it there, isn't it? So I'd fix it up slightly with a smaller rubber than that, and then I might just go, might just go a bit more direct. Okay, that's a bit better, right? Still not great. Now, so you guys are really trying to use a lot of pencil there and get it quite accurate, okay? Now that's done, okay? What we're going to do next is we got to draw the line. Now what's the great thing about lines? What do I need to draw only in a line? The first point and the last point. So that's -4 goes down to -6, and then finally the other one is 2, 0, which is located here. And then we're going to get a graph like so. That's it there, isn't it? Okay guys. Now, just to be sure, you might want to dot your points. So we're going to get -3, -5, -2, that one there, -1, that one there, 0, -2, 1, -1. So you can see I dotted off the points anyway, just to be sure. Alright guys, let's answer some questions. What is the roots of the equation x squared plus 3x minus 3 equal to 0? Can anyone tell me that? Part 1. What's the answer to part 1? What is the roots of it? Anybody? The question is f of x equals 0. What does that mean? Y value of the curve equals 0. So where does that cross? Here and here. Give me a value for both of them. 4.75, 4.7, minus 4.7? Yeah? Sorry? Oh, sorry, minus 3.7. Yeah? And what about the other one? I go for about, let's compromise 0.8. Okay, let's try 0.8. Okay guys, what about equals -2? Oh, what happens when it equals -2?
You go to -2 and go down the line.
y equals minus 2, go crossing the line. Okay, here it is here. I won't use a green line, use a black line. Hits and goes up. This one here hits and goes up. So what's our two answers? Sorry, I made a quick mistake on that one. What's our two answers then? This one here?
Minus
3.3-ish.
yeah.
Okay, and what about this one here?
3.5.
It's not 0.5, it's 0.33, 0.671, because it's in 3 blocks. Okay? So it'll be 0.3. Now, do you see the way my bigger diagram has made our answers more accurate? The bigger you can make those, the bigger you can spread out the gaps, the better. So it's going to be minus 0.33 and 0.3. So it's going to be x equals minus 3.3, x equals 0.3. Finally, the roots of the equation f of x equals g of x. What does that mean? F of x equals g of x. The y value of the equals the y value of the perfect. Y value of curve equals y value of line. Where does this happen? Here and I might need to get rid of this for a second. Okay, here. Look at these two. Now guys, let's look at this. Okay, we'll just draw lines up from them, red lines. Okay guys, so we're talking about this part here, and this part here. What's those two values then, would you say? Minus 2.3 and here? About 0.4. Minus 2.3 and 0.4. Who got that out? Okay. The minimum value of f of x. What's the minimum value? We cheated, didn't we? We calculated, didn't we? Jack calculated it earlier. What is it? Minus 5.25. That is minus 5.25 for that one. What is the mean of f of x is smaller than g of x? Anybody? When is the y value of the curve smaller than the y value of the line? When is the blue line beneath the, when is the blue curve beneath the green line? Let's find out. Let's start off at x equals 4. Which one's bigger, blue or green? Blue is above green. Blue is still above green. Blue is still above green. Now all of a sudden at this point here, which we called earlier was 2 points, x equals 2.3, they're now equal. Now all of a sudden the curve is beneath the line. It's beneath, it's beneath, it's beneath, it's beneath. Now it's equal. When does this stop? We gave it a value of 0.4. So the answer is in between minus 2.3 and 0.4 is when the curve is beneath the line. Does everybody understand that? Okay. Okay. So number 14. The diagram below shows the graphs of f of x equals x squared minus 6x plus 9. G of x equals x squared minus 3x plus 3. By substituting x equals 0 or any other value of x into each equation, work out which graph is which. Okay. If I replace f of x with 0, I get f of 0. F of 0 equals 0 squared minus 6 times 0 plus 9. The answer to this is 9. This means when the input is 0, the output is 9. This means that it's more than likely the blue curve. Does everybody see the blue curve? Why do I think it's the blue curve? Because 9 isn't in the graph, is it? Let's check out the red one then. G of x equals, we're going to find g of 0, which is 0 squared minus 3 times 0 plus 3. The answer for this is 3. This means the point 0,3 is on this curve. Is the point 0,3 on the red curve? Yes. This means g of x is red and f of x is blue. Which, use the graph to find out one value for which the y value of the curve, y value of the blue curve equals the y value of the red curve. It's located here. What x value is that? X equals 2. Why has the equation f of x only have one root? Why does it only have one root? It has two roots when the graph cuts it twice. Do you understand? Why does this one only have one root? Only touches it once. Curve touches x-axis in one position only. Okay guys.